Welcome to your Genshin Impact Miliastra Sandbox basic tutorial, Building My First Wonderland. In Genshin Impact's Miliastra Wonderland, not only can you use simple tools to design your own games, you can also explore a wide variety of creative games created by other players. In this course, we will walk you through building a complete Wonderland and teach you how to use the main basic features of Miliastra Sandbox. In this stage, the player needs to collect the target number of coins to attain victory in the Wonderland. The player will face 3 obstacles while collecting the gold coins. First, the player needs to take the elevator that moves up and down to reach the platform above. Then, they need to activate the stone slabs using the interactive device. After that, they have to get across before the stone slabs collapse. Next, the player has to light up the 4 torches to unlock a weapon. Picking up the weapon grants combat abilities. Once you defeat the enemies, you will level up to level 40. Keep going. Then use the moving platform to get to the other side. Defeat the enemies here to level up to level 90. Finally, defeat the final boss to get the gate key. Open the gate with the key to collect the remaining coins. Unlock the device, watch the fireworks go off, and claim your victory. Note, some content can only be implemented after you reach Craftsperson Level 3. If you are not yet at Craftsperson Level 3, you will not be able to see this content during the test play. In this course, we'll teach you to build this Wonderland step by step through 3 parts: component setup, process logic configuration, and gameplay integration. Before we start building the Wonderland, we need to import the terrain and the provided assets. Click Import Save, select Scene Terrain, and click Open. The terrain we just imported will then be shown in Save File page. Click Edit. Next, let's import the coins, weapons, and related node graphs we created earlier. Click the top left corner and select the Manage Asset Import Export tool. You can import assets in the Import and Transfer section. Click Load External Assets, then open the directory. Copy the assets and node graphs we want to import into this folder. Then click Load External Assets again. Right-click to view the combination package assets. Select all assets, then click Transfer Selected Assets. You can see the imported assets in the Assets Exporting section. You can view the imported prefabs in the prefab library. Since the player's custom variable, score value, wasn't imported, we need to set it up again. Go to the Combat Preset screen and click Advanced Editing. Add a new variable for the player. Rename the variable to score value. Set the variable type to integer. Set the initial value to 0. Mount the imported node graph, Player Finalize Wonderland on the player. Now we can start creating the components. Now, let's start making prefabs that require the use of basic motion devices for the Wonderland. For this Wonderland, the components we need to create include moving platforms, controller mechanisms, the resetting stone slab, ignitable torches, collectible weapons, 3 enemies with different combat strength levels, a key, a chest, an interactive gate, and a Wonderland exit device. First, let's make an up and down moving platform and a left and right moving platform. Go to the prefab library screen. Find stone moving platform in the gameplay mechanism section. Add a basic motion device component to it. Click Advanced Editing. Click the addition sign to add a motion device. Change its name to Up-Down Movement. Enable Initially Effective. Set Motion Type to Path Movement. Set Loop Type to Round Trip. Next, add a waypoint, set all coordinates to 0, and set the speed to 3. Set the y-axis value of the waypoint to 6. Click Preview Current Motion to check the effect. Save the prefab and rename it Up-Down Moving Platform. Similarly, add a basic motion device component to another platform. Click Advanced Editing. Click the addition sign to add a motion device. Change its name to Left-Right Movement. Enable Initially Effective. Set Motion Type to Path Movement. Set Loop Type to Round Trip. Next, add a waypoint and set the speed to 4. Set the z-axis value of the waypoint to 12. Click Preview Current Motion to check the effect. Save the prefab and rename it Left-Right Moving Platform. Place the finished prefab in the object placement screen. Click Test Play to check the effect. Next, let's make a controller mechanism. Find stone mechanism in the gameplay mechanism section. Add a tab component to it. Click Advanced Editing. Change the tab icon. Rename the tab to Activate. Click Trigger Option area. Change the center y-axis value to 1. Change all zoom multiplier values to 2. Save the prefab and rename it Controller Mechanism. And that's it. You've created a controller mechanism. Next, let's make a stone slab that resets after being triggered. Find Stone Elemental Platform in the Gameplay Mechanism section. Add a basic motion device component to it. Click Advanced Editing. Click the addition sign to add a motion device. Change its name to Ascend. Disable Initially Effective. Set the motion type to Uniform Linear Motion. Set the effective duration to 2 for now. Set the y-axis value of the relative location at the destination to 6. This will make the stone slab reset upwards. Click Preview Current Motion to check the effect. Save the prefab and rename it Stone Slab. And that's it. You've just created a resetting stone slab. Drag all finished devices and stone slabs into the object placement screen. Since we need to activate the stone slab through the interactive device, we should add a node graph to the interactive device to make this work. Open Miliastra Sandbox. Right-click and select Create Node Graph. Rename the node graph to activate Stone Slab. Selecting the tab activates the stone slab's basic motion device. To query the target entity, use its GUID, which is the GUID of the stone slab in the object placement screen. Close the tab after the basic motion device is activated. Save the node graph. Attach it to the interactive device. And overwrite to save the prefab. Now, we can activate the stone slab through the interactive device. Click Test Play to check the effect. Next, let's create the effect where the stone slab collapses 1.5 seconds after being stepped on. Click on Elemental Stone Platform to add a collision trigger component. then click Advanced Editing. Add a trigger and enable Initially Effective. Set the effective target to characters. Change the center Y-axis value to 1. Change all zoom multiplier values to 4. Open Miliastra Sandbox. Right-click and select Create Node Graph. Rename the node graph to Stone Slab Collapse. When the player enters the collision trigger, a timer will start. Connect the timer sequence with an assembly list and set the value to 1.5. The target entity should be the trigger entity, the stone slab. When the timer is triggered, after 1.5 seconds, it will play the collapse effect and destroy the stone slab entity. The target entity for these actions should be the event source entity, the stone slab. Save the node graph and attach it to the stone slab. Overwrite and save the prefab, then click Test Play to view the effect. This completes the creation of the relevant prefabs for a basic motion device. Next, let's create the VFX prefabs we'll use in the Wonderland. Our goal is to create a torch that can be ignited. In the Gameplay Mechanism category, find Elemental Torch. Add a tab component to it. Click Advanced Editing. You can modify the tab's icon. Change the tab's name to Ignite. Click on Trigger Option area. Change the center Y-axis value to 1. Change all zoom multiplier values to 2. Let's add a node graph to the component so that when the tab is clicked, the Ignite effect plays. Open Miliastra Sandbox. Right-click and select Create Node Graph. Rename the node graph to Ignite Torch. When the player enters collision trigger, it will play the effect, then close the tab. The target entity for these actions should be the event source entity, the torch itself. Set the location offset Y-axis value to 1.2. Save the node graph and attach it to the torch. Then, save the prefab and name it Torch. Finally, place the prefab on the object placement screen and click Test Play to see the effect. This completes the creation of the VFX prefabs. Next, let's create a weapon that can be picked up. In the other category, find Empty Model. Add a collision trigger component to it. Click Advanced Editing, add a trigger, and enable Initially Effective. Set the effective target to character. Change the center Y-axis value to 0.5. Change all zoom multiplier values to 1.5. In the component list, find VFX Playing and click Advanced Editing. Click Add VFX. Set the VFX asset type to Looping Effects. Add a Sword 01 effect to it. Set the offset Y-axis value to 0.7. Set the rotate X-axis value to 90. Click the play button to see the effect. Disable the prefab's native collision, save the prefab, and rename it to Weapon. And just like that, you've created a collectible weapon. Now, let's create a combat class. After a player collects or picks up a weapon, they can switch to this class to enable combat functionality. Go to the Combat Presets screen and find Class. Click Create Class and rename it to Swordsman. Set the base HP to 100. Set the attribute growth to default growth curve. Open the Skills module on the right side panel, then click the addition sign to add a skill. Select the previously imported skill, Normal Attack. And just like that, you've created a class with a combat skill. Let's add a node graph to the weapon prefab, which will allow the player to switch classes. Open Miliastra Sandbox. Right-click and select Create Node Graph. Rename the node graph to Gains Combat Ability. When the player enters the collision trigger, their class is changed. The target class should be the ID of the swordsman class. The target player needs to be obtained using the Get the Player entity to which the character belongs node. After the player's class is changed, the weapon entity is destroyed. The target entity for this action should be the trigger entity, example, the weapon. Next, attach the one-handed sword effect to the character's right hand. The target entity for this action is the entrant entity, example, the character. Save the node graph, attach it to the weapon, and overwrite and save the prefab. Place the prefab on the object placement screen, then click Test Play to see the effect. This completes the creation of the player's class and skills. Next, let's create 3 enemies with different combat strength levels. Click Creation Prefabs. Find Hilichurl in the Hilichurl section under Creations. Find Large Hydro Slime in Elemental Lifeforms. And find Ruin Grater in Automatons. These will be our enemies. Set the faction of these 3 enemies to Initial Creation Faction. Open the faction section in Stage Settings. Click Faction Relations in Initial Creation Faction. Set the relationship between the Initial Creation Faction and the Initial Player Faction to Hostile. Set the relationship between the Initial Creation Faction and Initial Object Faction to Friendly. Click on Large Hydro Slime and change the level in its basic battle attributes to 20. Click on Ruin Grater and change the level in its basic battle attributes to 40. Save the prefabs, and now the 3 enemies are done. Next, let's implement the effect where defeating a Hilichurl raises the stage level to 40. Open Miliastra Sandbox. Right-click and select Create Node Graph. Rename the node graph to Level Up to 40. When an entity is destroyed, check if the event source GUID matches the Hilichurl's GUID. If they match, raise the player's stage level to 40. The player entity needs to be obtained using the Get Player entity to which the character belongs node. Place the Hilichurl in the object placement screen and get its GUID. Save the node graph and mount it on the stage entity. Click Test Play to check this effect.
Yeah!
Next, let's create the effect where defeating the Large Hydro Slime raises the stage level to 90. Open Miliastra Sandbox. Right-click and select Create Node Graph. Rename the node graph to Level Up to 90. When an entity is destroyed, check if the event source GUID matches the Large Hydro Slime's GUID. If they match, raise the player's stage to 90. The player entity needs to be obtained using the Get Player entity to which the character belongs node. Place the Large Hydro Slime in the object placement screen and get its GUID. Save the node graph, then mount it on stage entity. As the player needs to get to level 40 before they can defeat the Large Hydro Slime, we will set the level of the Swordsman class to 40 for testing. Click Test Play to check the effect. Next, we need to create a chest for storing the key later. Find Precious Chest in the Gameplay Mechanism section. Add a tab component to it. Click Advanced Editing. Change the tab icon. Rename the tab to Open Chest. Click Trigger Option Area. Change the center Y-axis value to 1. Change all zoom multiplier values to 2. Find VFX Playing in the component page and click on Advanced Editing. Under VFX Asset Type, select Looping Effects. Click Add VFX and select Lock Pattern. Disable Initially Effective under the Chests tab. Save the prefab and name it Chest. And that's it. You've created a chest. Next, let's create the effect where defeating the Ruin Grader unseals the precious chest. Open Miliastra Sandbox. Right-click and select Create Node Graph. Rename the node graph to Unseal Treasure Chest. When an entity disappears, check if the event source, GUID, matches the Ruin Grader's GUID. To lift the chest's seal effect, play the Unlock effect, and activate the Chests tab. Place the chest and Ruin Grader in the Object Placement screen and get their GUIDs. Save the node graph and mount it on the stage entity. Return to Miliastra Sandbox. Right-click and select Create Node Graph. Rename the node graph to Open Treasure Chest. When the tab is selected, set the chest to open, then close the Chests tab. Save the node graph, mount it on the chest, and overwrite to save the prefab. Since defeating the Ruin Grader requires stage level 90, we'll set the Swordsman class stage level to 90 for testing. Click Test Play to check the effect. At this point, we've completed all monster-related functions. After testing, set the Swordsman class stage back to 1. Now, let's learn about collisions and interactions by creating 3 components. These include lighting 4 torches to unlock a weapon, picking up a key to open a wooden gate, and clicking a tab to exit the Wonderland. First, let's implement lighting 4 torches to unlock a weapon. Since we need to count the torches, we'll first set up a custom variable. Go to the Combat Presets screen. Click Advanced Editing for Custom Variable in the Component module. Add a new variable for the player. Rename the variable to Torch Count. Set the variable type to integer. Set the initial value to 0. Next, modify the node graph Ignite Torch. The calculation logic for the custom variable torch count is the same as for score value. Add a set custom variable node to make the torch count increase by 1 when the Torches tab is clicked. Go to the Prefab Library screen and add a sealing effect to the weapon. Click Advanced Editing under VFX Playing. Select Looping Effects under VFX Asset Type. Add a red ring barrier effect to it. Click Preview Combination to preview all options. Disable Initially Effective for the Weapon Prefab's Collider and overwrite to save the prefab. Next, create a node graph with the name Unlock Weapon. When the custom variable torch count changes, compare the value with 4. When it's greater than 4, The weapon is unsealed. Activate the weapon's collider and play the weapon's unlock effect. The target entities here are all weapons. You need to use a query entity by GUID node to get the weapon's GUID. Place the weapon in the object placement screen and get its GUID. Save the node graph and mount it on the player. Place the 4 torches in the object placement screen. Click Test Play to check the effect. Next, let's implement. Pick up key to open a wooden gate. First, create the key. Find crystal mechanism in the gameplay mechanism section. Add a tab component to it. Click Advanced Editing. Change the tab icon. Rename the tab to Obtain Key. Click Trigger Option Area. Set the center Y-axis value to 0.5. Set all zoom multiplier values to 2. Save the prefab and rename it Key. And that's it. You've created the key. Next, let's make an interactive gate. Find wooden fence in the gameplay mechanism section. Add a tab component to it. Click Advanced Editing. You can change the tab icon. Rename the tab to Open Gate. Click Trigger Option Area. Set the center Y-axis value to 1. For zoom multiplier values, set it to 6 for the X-axis, 6 for the Y-axis, and 4 for the Z-axis. Next, add a basic motion device component. Create a new movement path and rename it Ascend. Disable Initially Effective. Set the motion type to Uniform Linear Motion. Set the effective duration to 2. Set the Y-axis of the relative location at the destination to 3. This way, the gate can open upwards. Click Preview Current Motion to check the effect. Save the prefab and rename it Gate. Awesome! Now you've also created an interactive gate. Next, we need to link the key to the gate so that the gate can only be opened with the key. Set a custom variable key count to track whether the key has been obtained. Open the combat preset screen. Click on Advanced Editing and add a new variable. Rename the variable to key count. Set the variable type to integer. Set the initial value to 0. Then, we'll add a node graph to the key to activate the gate. Open Miliastra Sandbox. Right-click and select Create Node Graph. Rename the node graph to Pick Up Key to activate gate. The calculation logic for the custom variable key count is the same as for custom variable score value. Finally, add an activation tab to display the gate opening option. The target entity is queried using its GUID. Where the GUID is the gate's GUID, place the gate in the object placement screen and get its GUID. The tab ID is the ID in the tab component, which is 1 here. Select Yes for Activate. Save the node graph. Mount it on the key. And overwrite to save the prefab. Return to Miliastra Sandbox. Right-click again and select Create Node Graph. Rename the node graph to Open Wooden Gate. When the tab is selected, activate the wooden gate's basic motion device, with the target entity being the event source entity, example, the wooden gate. Save the node graph and mount it on the wooden gate. Disable Initially Effective for the Wooden Gates tab, and overwrite to save the prefab. Place the key in the object placement screen and click Test Play to check the effect. Finally, let's implement. Click Tab to exit the Wonderland. Find Pyro Elemental Monument in the Gameplay Mechanism section. Add a tab component to it. Click Advanced Editing. Change the tab icon. Rename the tab to Exit. Click Trigger Option Area. Change the center Y-axis value to 1. Change all zoom multiplier values to 3. Open Miliastra Sandbox. Right-click and select Create Node Graph. Rename the node graph to Exit Wonderland. When the tab is clicked, the player's settlement status is set to Victory, and the game proceeds to result settlement for the stage. The player entity needs to be obtained using the Get Player Entity to which the character belongs node. Save the node graph and mount it on the Pyro Elemental Monument. Save the prefab and name it Wonderland Exit Device. Place the Wonderland Exit Device in the object placement screen. Then click Test Play to check the effect. At this point, we've completed all prefabs related to collisions and interactions. After finishing all the components, we can now implement the following 3 logics, all of which require the player to meet certain conditions to trigger. 1. A hilichurl appears after weapon is picked up. 2. Grant key when chest is opened. And 3. Trigger the victory effect when the target score is reached. First, let's implement. A hilichurl appears after weapon is picked up. Set up a custom variable to store the spawned hilichurl entity. Click on Stage Entity. Click Advanced Editing for custom variables in the component module. Add a new variable for the player. Rename the variable to hilichurl. Set the variable type to Entity. Place an empty model in the object placement screen to serve as the spawn position for the hilichurl. Disable its native collision. Open the Obtain Combatability node graph and add a Create Prefab node. The prefab ID is the hilichurl's ID. Use the empty model's GUID to set the position of the hilichurl after spawning. Add a Set Custom Variable node. The target entity is the player entity, variable name is hilichurl, and variable value is spawned entity. Save the hilichurl entity. Open the node graph named Level Up to 40. Add a Get Custom Variable node, with the target entity set to Event Source Entity and variable name set to hilichurl. Connect input 2 to variable value. At this point, the hilichurl entity is retrieved, and the stage level increases when the event source entity is the hilichurl entity. Save the node graph. Place the weapon in the scene, and enable Initially Effective for the collision trigger. Click Test Play to check the effect. Next, let's implement. Grant key when chest is opened. Open the node graph, open treasure chest. Create the key prefab before destroying the chest entity. The key prefab here is the one we made earlier. Copy the prefab ID over. Get the chest's rotation and position. Connect them to the rotation and position of the Create Prefab node. Save the node graph. Then place the chest in the object placement screen. First, enable the tab and disable it after testing. Click Test Play to check the effect. Finally, let's implement. Trigger the victory effect when the target score is reached. Specifically, after the player collects all gold coins, the fireworks effect will trigger, and the Wonderland exit device will be activated. Open the node graph named Player Finalize Wonderland. Modify the node graph so that when the value reaches 5, the preset state of the Wonderland exit device is changed. Then mount the red light beam effect. Then activate the device's tab. With the exception of VFX playing, set all target entities to the Wonderland exit device. Use GUID to retrieve the entity. Place the Wonderland exit device in the object placement screen to get its GUID. Then, create an empty model as the target entity for playing the fireworks effect, where the GUID is the GUID of the empty model in the object placement screen. Save the node graph. Disable Initially Effective for the Wonderland Exit Device tab. Place the 5 gold coins in the object placement screen and click Test Play to check the effect. After we set up all the components and process logic, we can integrate everything into Wonderland gameplay. First, let's build the Wonderland. We place objects into the scene in the order they'll be encountered during gameplay. Go to the object placement screen and place the up-down moving platform. Preview current motion to check the effect and adjust the position if necessary. Place the controller mechanism at the cliff edge. Next, drag out 5 stone slabs and arrange them together to form a stone bridge. Place the stone bridge in the water, click on the stone slab, and modify its node graph. Activate stone slab. Copy 4 sets of the Activate Basic Motion Device node and query entity by GUID node. Copy and paste the GUIDs of all 5 stone slabs into the nodes. Save the node graph. Preview current motion to check the effect and adjust positions if necessary. Place the weapon and torches on the second terrain block. Open the node graph, unlock weapon. Update the weapon's GUID in the node graph. Save node graph. Place the 2 left-right moving platforms in the 2 gaps between these 3 terrain blocks. Place 1 up-down moving platform between the last 2 terrain blocks. Preview current motion to check the effect and adjust positions if necessary. place an empty model as the hilichurl spawn point. Open the node graph, obtain combat ability. Update the empty model's GUID in the node graph. Save the node graph. Finally, place the large hydro slime, chest, ruin grater, wooden gate, and Wonderland exit device on the terrain. Open the stage up to 90 node graph and update the large hydro slime's GUID in the node graph. Open the unsealed treasure chest node graph and update the ruin graters and chests GUIDs in the node graph. Open the pickup key to activate gate node and update the wooden gate's GUID in the node graph. On both the left and right sides of the Wonderland exit device, place an empty model each for fireworks ignition. Open the Player Finalize Wonderland node graph. Add another VFX playing node. Update the GUIDs of the Wonderland exit device and fireworks positions in the node graph. Change the greater than or equal to value to 30. Finally, place 30 gold coins around the scene. Then use empty models to add invisible walls, air walls at the scene's boundaries. Disable the climbable option for some terrain blocks, prefabs, and air walls. Click Custom Page tab in the top left corner. Open Preset Point Management. Here, there is already a default spawn point, and we just need to create a revive point. Click to create a preset point and name it Revive Point. Then, click Custom Page tab in the top left corner again. Open Stage Settings, open Revive Point, select Revive Point from the points list. Place the previously set Revive Point in a suitable location in the scene. Here, we'll place it at the start point. With this, our Wonderland map is fully built. Next, let's create the information displayed in the interface. This includes the real-time displayed score value and key count, as well as prompt guidance. First, let's display the current score and key collection progress in the interface. Click Custom tab in the top left corner. Open Manage UI Control Groups. Click UI Control Group Library, add an UI Control template. Select Text Box. Change the text content to score value. Insert the variable Click on the player and select Score Value. Adjust the position and size of the text box. Finally, click Save as Template. Rename it to Text Box Score Value. Now, let's add another UI control template. Select Text Box, change the text content to Key Count, insert the variable, click on the player, and select Key Count. Adjust the position and size of the text box. Finally, click Save as Template, rename it to Text Box Key Count. Open Interface Layout. Click Add UI Control. Add the two finished text boxes to the interface. Now, the prompts for player score and key collection progress are done. In addition, we need to provide the player with prompts for what to do next and for the display of stage completion conditions. Let's first create the prompt information, then set the trigger points for these prompts. Click UI Control Group Library, add an UI Control template. First, let's create a pop-up for the Wonderland's completion condition prompt. Select Pop-up, change the title to Stage Completion Rules. Change the text content to collect all 30 gold coins to clear the stage. Make sure you collect every coin. Adjust the position and size of the text box. Disable initial visibility. Finally, click Save as Template. Rename it to Pop-up Wonderland Description. Next, add an UI control template for the Stage 3 prompt. Select Text Box. Change the text content to find a weapon to gain combat abilities so that you can defeat the enemies ahead. Set the background color to black translucent. Adjust the position and size of the text box. And center the text. Disable initial visibility. Finally, click Save as Template, rename it to Text Box Find Weapon. Add another UI control template for the Stage 4 prompt. Select Text Box. Change the text content to You need a key to open the gate. Follow the same steps as the previous prompt. And finally, rename it to Text Box Find Key. Next, add the finished pop-up and text boxes to the interface. Open Interface Layout. Click Add UI Control. Now, you've created all the needed prompt information. We'll also need to set up a trigger point in the scene so that when the player arrives, a prompt will be displayed. First, set the trigger point. Go to the Object Placement screen, create an empty model, disable Native Collision, add a collision trigger component to it. Select Character for effective target. Set the center Y-axis value of the trigger area to 1. Set the scale factor X-axis value to 4. Set the Y-axis value to 2. Set the Z-axis value to 8. Next, let's create a node graph so that the prompt is displayed when the player enters the trigger area. Open Miliastra Sandbox, right-click and select Create Node Graph. Rename the node graph to Pop-up Wonderland Description. When the player enters the collision trigger, the UI control group state is changed to enabled. When the player leaves the collision trigger, the UI control group state is changed to disabled. The target player has to be obtained via the Get the Player Entity to which the character belong node. Select Pop-up Wonderland Description for the UI control prefab index. Save the node graph. Mount the node graph on the newly created empty model. You've now set up the first set of prompt triggers. Now, let's move on to the start of Stage 3 using Use the Same method. Create an empty model. and disable native collision. Add a collision trigger component to it. Select character for effective target. Set the center y-axis value of the trigger area to 1. Set the scale factor x-axis value to 6. Set the y-axis value to 2. Set the z-axis value to 4. Similarly, create a node graph that displays a prompt when the player enters the trigger area. Open Miliastra Sandbox. Copy the node graph pop-up Wonderland description. Paste the node graph and rename it to text box Find Weapon. Select text box Find Weapon for the UI Control Prefab Index. Save the node graph. Mount the node graph on the newly created empty model. Finally, move to the wooden gate and create another empty model with native collision disabled. Add a collision trigger component to it. Select character for effective target. Set the center y-axis value of the trigger area to 1. Set the scale factor x-axis value to 4. Set the y-axis value to 2. Set the z-axis value to 6. Create another node graph that displays a prompt when the player enters the trigger area. Open Miliastra Sandbox. Copy the node graph text box Find Weapon. Paste the node graph and rename it to text box Find Key. Select text box Find Key for the UI Control Prefab Index. Save the node graph. Mount the node graph on the newly created empty model. Now you've placed all the necessary prompt information. The Wonderland is finished. Now let's start testing the game. Return to Miliastra Wonderland, click on Custom tab in the top left corner, click Test Play. After you enter the Wonderland, the first thing you'll see is the stage completion rules pop up. Close the pop-up. Any gold coins you collect will add to your score. In Stage 1, take the lift to reach the upper platform. In Stage 2, click the tab on the interactive device. All the stone slabs will rise. The stone slabs will collapse 1.5 seconds after you step on them. So you'll need to quickly cross the stone bridge. Then we move on to Stage 3. A prompt to find a weapon will appear. Ignite 4 torches to unlock the weapon. After you pick up the weapon on the ground, you'll gain combat abilities. An enemy will appear at this moment. After you defeat the enemy, you will level up to level 40, keep moving forward, and use the moving platform to reach the other side. After you defeat the enemy there, you will level up to level 90. In the final stage, we move forward to fight the final boss. After you defeat the boss, open the chest to get the key. When you reach the gate, a prompt appears. You need a key to open the gate. Use the key to open the gate. Collect the remaining gold coins. Once you reach the target score, the Wonderland exit device will activate and the fireworks effect will trigger. Select Exit Wonderland and the victory animation will show. The test play runs smoothly? Congratulations! You've successfully built a Wonderland. After you finish building the Wonderland, you can export it to share it with other players. You will use this feature frequently if you need to collaborate with other craftspeople on Wonderland building. Go to the Save File page. Take your mouse over the project you want to export and click on the 3 dots. Click Export, make changes to the file, save location and name in the dialog box as necessary, then click Save. We can also export specific assets individually. To do this, we'll use the Manage Asset Import-Export tool. Select Assets Exporting and click on the asset you wish to export. For the purposes of demonstration, we'll select the 2 moving platform prefabs. Click Export Asset, make changes to the file's save location and name as necessary, then click Save. So, I hope everything in this course is clear to you by now. Now, it's time for you to share your creative ideas with your friends. Try creating a Wonderland that's uniquely yours. Enjoy your time in the world of Miliastra Wonderland, and see you in the next tutorial.